In this video, we're going to use the AA similarity postulate, SAS similarity theorem, and SSS similarity theorem to prove when two triangles are similar. So let's take a look at each one of those theorems and postulate. First is angle, angle. That's what the AA stands for. So notice in this picture here, I have triangle ABC and triangle SRD. Notice that A has one curve, D has one curve. That means those angles are congruent. B has two curves, S has two curves. That means those angles are congruent. So now that we know we have two sets of angles congruent, we have enough information to be able to prove those triangles are similar. We don't have every piece of information, but we have enough information to be able to show that through that angle-angle postulate. So I could then write the similarity statement that triangle ABC is similar to triangle DSR. Notice the order that I put them in, that A matches with D, B matches with S, and C matches with R by the AA similarity postulate. So that's like our reason. This similarity statement is our statement, and the postulate is our reason for that conclusion. Next we have side-side-side similarity. We know in similar figures that the sides are going to be proportional. So if we have the SSS similarity theorem, all of our sides have to be proportional. So I'm going to need to match up my sides. Now how do I know which one goes where? Well, the shortest side is always going to be corresponding to the shortest side in the other triangle. So I could put 2.8 and 4.2 in a ratio. The longest side is always going to match or be corresponding to the longest side. So 7 is the longest side in triangle ABC, and 10.5 is the longest side in SRD. So here I know, again, that the middle values will also match up. Once I reduce these fractions down, I notice that they match, and therefore the sides are then proportional. And I could also check each cross product, so 2.8 times 9.3 is 26.04. 4.2 times 6.2 is also 26.04. 6.2 times 10.5 is 65.1. 9.3 times 7 is also 65.1. So I've checked two sets of sides. Let's check the third set. 2.8 and 10.5 is 29.4. 7 times 4.2 is also 29.4. So we have now proven by SSS similarity that triangle ABC, now notice in this one that S will actually match with A, B will match with R, and C matches with D. So triangle ABC is going to be similar to triangle SRD. Here we have side, angle, side. Notice that angle is between the two sides in the name. It's also going to be that way in our two triangles here. The angle has to be included between the two sides. Remember in similar figures that angles are congruent that are corresponding, and sides are proportional. So I have 6, which is the shorter side in this triangle, that will match with 18. So those are corresponding pieces. 7 is the longer of the two sides, which will match with 21. If I reduce both of those fractions, I get 1/3. So I know that they are proportional. I could also check the cross product. 6 times 21 is 126. 18 times 7 is also 126. So I know that those are proportional. So I have two sets of sides that are proportional, and the included angles that are congruent. Therefore, by the SAS similarity theorem, or side-angle-side similarity, I know these two triangles are similar. Right here I have two triangles. It gives me some information about those triangles. Angle B and angle E are right angles, so I have 90 degrees in both of those angles. I also have angles C and F that are 30. If both of those angles are 30, then we know their measures are equal, therefore angles C and F are congruent. So write a similarity statement for the two triangles. Well, we know that they are similar because we have two sets of angles that are congruent. So by our AA similarity postulate, we know triangle ABC is similar to triangle DEF. Now explain how the similarity statement can be used to find the missing side measures. Well, now that we know the triangles are similar, we know that the sides are proportional. So if the sides are proportional, we can set up a proportion to solve for that missing side length. So cross multiply that proportion. So 5 times x equals 32. Divide by 5 and we get 6.4. So that missing side right there is 6.4. Okay, take a look at our triangles here. We have a triangle inside a triangle here. We have triangle RMN and triangle RTS. Now we're going to answer some questions about those. We're given some information. We're given that we have parallel lines. If we know we have parallel lines, we know we have parallel lines and transversals properties. So if those are parallel, then RS is a transversal for those parallel lines. Therefore, we know those corresponding angles are congruent, so that's 67. We also know that RMN has to be 43 because those are corresponding angles as well on those parallel lines, and RT is the transversal. So what we want to determine is if the two triangles TRS and MRN are similar. So we can solve for angle RMN, which was 43, and angle R is shared in both triangles. Notice that R is a vertex for both triangles. So by the AA similarity theorem, we know triangle RMN is similar to triangle RTS. Notice we could have written that statement differently as long as our pieces still match up. Now, what I want you to do is use that given information and solve for the missing side lengths. Keep in mind, you might have to add some pieces together to get RS or RT to be able to use that in a proportion. Okay, and also these are 4 practice problems I want you to do. Give the appropriate theorem or postulate that can be used to prove the triangles similar, and write the similarity statement. So the similarity statement is the statement like this, where two triangles are similar to one another. So try these 4 problems. Use your AA similarity, your SAS similarity, or SSS similarity.